Did you know that the same water you drink every day, the stuff you trust to douse flames, can actually catch fire and explode? It sounds impossible, right? After all, water is the universal firefighter, but under the right conditions, it becomes the fuel for one of the most intense chemical reactions on Earth. How is this even possible? And what does it take to turn something as harmless as water into an explosive force? Stick around, because this one fact could completely flip how you think about the world around you. Water. It's essential for life, the go-to solution for extinguishing fires, and something we take for granted as being completely safe. But here's the twist. Water is made up of hydrogen and oxygen, two gases that are famously flammable. When separated and reintroduced in the right way, they can unleash an explosion so powerful it could blow your mind. Literally. This isn't some hypothetical lab experiment, it's real, it's science, and it could even happen in your own home under the right conditions. Today, we're diving deep into how water, the life giver, can also be a potential life taker. For most of us, water is synonymous with safety, especially when it comes to fire. But what if I told you there's a hidden danger lurking inside every glass of water? It's not the water itself, but its molecular makeup. Hydrogen, one of its components, is the same gas that fueled the Hindenburg disaster, while oxygen is essential for combustion. So why doesn't water just blow up every time you pour it on a campfire? The key lies in the strong bonds holding those hydrogen and oxygen atoms together. But when those bonds are broken, say by introducing a high-voltage current, things take a very different turn. Let's break this down. Water is made up of H2O molecules, two hydrogen atoms bonded to one oxygen atom. These bonds are incredibly stable, which is why water doesn't spontaneously combust. However, when you apply a high enough voltage to water, you can split these molecules apart in a process called electrolysis. Electrolysis separates the hydrogen and oxygen gases. And here's where the magic, or danger, happens. Hydrogen is highly flammable and oxygen is an accelerant. When these two gases are mixed in the right proportions and exposed to a spark, the result is an explosion that can rival dynamite. In fact, this reaction is so powerful that it's used in rocket engines to propel spacecraft into orbit. That's right, the same principle that can make water burn is helping us explore the universe. But it's not just about rockets. This reaction has practical applications on Earth too. For example, hydrogen fuel cells rely on splitting water to generate clean energy. Yet, the same process that promises a sustainable energy future also comes with risks. Mishandle the hydrogen and you've got yourself a potential disaster. Now, let's talk about one of the most dramatic demonstrations of this phenomenon, the hydrogen balloon experiment. Imagine a balloon filled with hydrogen gas. When a lit match is brought near, the balloon doesn't just pop. It explodes with a force that can shatter windows. This is exactly what happens when hydrogen and oxygen combine in the presence of an ignition source. It's a perfect illustration of how water, when broken down, can transform from a benign liquid into a volatile force of nature. And while this is controlled in scientific settings, accidental hydrogen-oxygen reactions have caused industrial accidents that are anything but controlled. So the next time you look at a glass of water, remember, it's not just a life-sustaining liquid. Within it lies the potential for immense power, both creative and destructive. Water's ability to fuel fire might seem like a paradox, but it's a testament to the incredible complexity of the natural world. This simple substance, essential for life, holds secrets that could one day revolutionize energy or, under the wrong circumstances, unleash unimaginable destruction.